Alright, so now let's pull out some properties for logarithms. So let's recall what we have seen. So we understand now that this thing is nothing but the inverse function of this function that I'm writing over here. This thing is inverse function of this, the function given by this equation, and that's why we understand this equation. So if I want to connect with this equation, I will simply write this in exponential format where b bar y will be x. So the role of input and output is exchanged, and we get an exponential format, and we are familiar with this. We can work on this. So whatever we do, we can always convert into exponential format, but since we will be using this function now frequently, so it will be handy to just pull out some properties, and those properties won't be new properties. They are just mirror images of whatever properties we have for exponential functions. So let's quickly jot them down. So these are properties for logarithms. So first thing that we need to put over here is that if I have a logarithm of base b, and we are talking about log of x bar p with the base b, then this bar, it can come out. So this p can come out. It can be put here. So I can write it like this. And actually this holds for x positive. So whenever x will have signature, then we also need to put a modulus over here depending upon p. Anyway, just to keep it simple, let me write that x is positive here. So if x is negative, then we need to bring in, so let me write the complete version. So I will put a modulus over here for completeness sake. Right, so this is the first property, and this allows us to do many computations, like if I want to see what is log 8 base 2, and first technique I can use is I can always convert it into exponential format and get my answer from there. Or now, since we have this property, so just let me write 8 as 2 cube. So we are talking about log of 2 cube, and this is 2. So that is going to be 3 log 2 base 2. And log 2 base 2 is going to be 1. So before this, actually, I should have mentioned this property. So let me pull this down, and we'll take this as second property, whereas first property that I want is, that is going to be that log of b to the base b. When the input and base, they match, that gives us 1. And the justification is pretty simple. We can just convert it into exponential format, wherein we see that b power 1 should be, b should be equal to b power 1. And I see that I have converted this thing into logarithmic format, wherein this just means that log b base b should be 1. So this is 1, and let me call this one a, and 1b, I will also declare one more thing, that log 1 will always be 0. So that thing is also pretty clear, because 1 is always b power 0. So for a valid base, b power 0 is 1. So we are just converting this thing into a logarithmic format. Right, so these two things we'll keep in mind. Whenever input and base, they match, that gives us 1, and log of 1 to any base is always 0. And now we have launched another property wherein this power can be brought out. So, but we have to take care, if x is negative, then we have to put a modulus over here, and we have used this property in this computation. So let's bring up the product rule then. Product rule looks like this. So log of, let me call it xy, log of xy to the base b, that is going to be equal to log of x base b plus log of y base b. So whenever inputs are multiplied, we can just open it up like this, where logarithms are going to be added. So this product here between the inputs is getting converted into addition of outputs. And this thing is coming out from a relevant property of exponentials. We understand that b power x plus y can be expressed as b power x, b power y. So this thing is just a reformulation of this. So if I just assume this thing to be, let's say alpha, and this is beta, then this side will come here, and this sum will just give me this. So it's just a reformulation of this. So this is product rule, and there is quotient rule as well. Quotient rule, which is, as we can guess, quotient inputs come in quotients x over y, and the base is b. Then that breaks up into log x minus log y, keeping base same. So the multiplication converts into addition, and the quotient, it converts into subtraction. And this thing, we can guess that it obviously is coming from the corresponding exponential property. B power x minus y is b power x over b power y. So it's just a conversion of this thing. And let me quote another one. Actually, it's just a cancellation property. So let me put it here like this. B power log of x to the base b, that is always x. So this is a nice property to have. So whenever this base of logarithm and exponential, they match, we can say that they cancel out each other, and we are just left with x. So this is just cancellation property, which is coming from the fact that logarithm is just the inverse function of exponential. So whenever they patch up, they cancel out the effect, and they cancel out each other's effect. Right, so these are 5 common properties that we use in computations. Let me quote another one, and the next one will also prove it. So let's say I'm talking about a power log of c to the base b. So we have seen over here that whenever these two things, they match, they cancel out. But here I'm talking about maybe they can be distinct. So a and b are arbitrarily chosen. So in that case, they won't cancel out. But we have a nice property that whenever this happens, keeping this b base fixed, the c and a, they can be exchanged. So c, this should be equal to c power log of a to the base b. So this base b is kept intact, and a and c have been exchanged. So we are going to call it exchange property. This is just cancellation property, and this is exchange property. And the quotient rule, product rule, let's call this as power rule, because power is coming out. So these are 6 basic properties, and we can compute fairly large amount of problems using just these things, and the basic definition of logarithms. Nothing special is required. We'll try to prove this thing, because that will give us idea of how to do computations in logarithms. Proofs as such, they are not needed, but it gives us better understanding of things. So we would like to write 1 or 2 proofs. So that we are going to do tomorrow. Till then, bye-bye.